Hey guys, today we're going to be talking about estimating products, and by the word products, I mean multiplication problems. I always run out of room, don't I? Multiplication problems. So go ahead and turn your books to page 101. We're going to be doing 1 through 5 as examples, and on page 102, we'll do number 18 and 19 together. Okay? So let's go to the next slide and write a couple of things down that we might need to know. Okay, so here's our notes. Make sure you get these down in your journal. There are a few things you need to understand before we move on to the practice problems, so I'll make a little star next to those things that are really important. I mean, I guess they're all important, but these words here, about, estimate, and approximately, those are all telling you that you're going to be rounding. So remember, when you're rounding to find an answer to a problem, you always want to round first, then solve. Round first, then solve. Plus, it kind of makes it easier when you're dealing with more zeros. And here's an example of that. If you look at the example here that I have 29 times 688, we round to the highest place value of each number. So we're rounding 29. So we ask ourselves, is it closer to 20 or 30? Well, you can see on the bottom, it's 30. And then for 688, the highest place value is the 100. So we'll round to that spot. Is 688 closer to 600 or 700? And there you can kind of see I have my two numbers I've rounded, 30 times 700. Now here's where it comes real easy when you're dealing with the zeros, right? The first thing you want to do is circle the numbers that are not zeros. So in this case, it's 7 and 3. I just multiply those. That's a simple math fact from 4th grade, right? 7 times 3 is 21. Then I'm going to count all the zeros from both numbers. So, for example, on 30, there's 1 0, and on 700, there's 2 zeros. So that's a total of 3 zeros, and I take those 3 zeros and I add them to the end of 21, and that makes my number 21,000. So that is my estimate of 30 times 700, or 29 times 688, is about or approximately 21,000. And then just real quick, I'm going to shrink this down and make sure and pause this slide if you need to get the answers here. But the numbers, so I can write this as 29 times, oops, let me go back on that one. 688 is about 21,000. I'm going to box that in. And remember, these numbers, 29 and 688, those are factors. And when you multiply two factors, you get the answer, or in this case, the mathematical term for answers of multiplication is a product. Okay? That's why this is called estimating product. We're estimating the answer. And there's two factors here. 688 and 29 are both factors. Okay? Let's go to the next slide. Okay, since we did number 1 already on the first slide, we'll start with number 2. And in the book that says, let's do that. Number 2 says 21 times 733. So we're going to follow the same rules that we put in our rules section of the notes, which is we're going to round to the highest place value, because these are all approximate, right? Estimates. So we're going to round to the tens here and the hundreds here. So 21 is closer to 20 times 700. Now remember, we go next door and we check the score. And it's 4 or less. We let it rest, we'd change it to a 0. 5 or more, we would increase it. So since this is 4 or less, we can just change it to 0. And that becomes 700. And the same thing like we did in the notes section is we circle the numbers that are not zeros. So we have 7 times 2, and 7 times 2 is 14. And then we can count the zeros. We have 1, 2, 3 zeros. So we add 1, 2, 3 zeros and put our comma there. And our answer is about 14,000. Now, I know in the book it says, is this an over or underestimate? And what they're saying there is when we went from 21 to 20 and we went from 733 to 700, did we round up or down? If we rounded down for both numbers, then this is an underestimate. Underestimate. And that's not really super important, but I know it says it in the book, so I just wanted you to understand, if you can even read what that says. But yeah, so that's what that means. If you rounded both numbers down, it's going to be an underestimate because you made them smaller. And if you rounded both numbers up, it would be an overestimate because you made both numbers bigger, right? 20 is smaller than 21. 700 is smaller than or less than 733. So those are both under, so they're underestimate. Makes sense, right? Not super important that you know that, but I just want you to understand that because it says it in the book. In case you had questions about that. Let's do number 3, which is 43 times 108. So now we can look at our two highest place values of 4 in the tens place and 1 in the hundreds place. 43 is closer to 40 times 108 is closer to 100. Way closer to 100 than 200. And then we can circle our non-zeros, which is 4 times 1. 4 times 1 is 4. And then we can count our zeros. We have 1, 2, 3 zeros, so we need 1, 2, 3 zeros. And we can add a comma. Now, another way to do this one, which would get you about the same answer, is also correct. If you left the 43 by itself, let's see what that would look like. If we left the 43 by itself and did 43 times 100, so we basically only rounded one of them. This is still kind of easy to solve, right? We would get close. We would get approximately the same answer. 4 times 1, or actually, in this case, it would be easier just to say 43 times 1, right? Because those are the non-zeros. So 43 times 1 is 43, and then we add 2 zeros, 1, 2, 1, 2, and that's 4,300, 4,300, which is relatively close to 4,000. So you could have used 40 as rounded or kept it 43. But when you multiply it with zeros, it gets pretty easy. It's actually fun. I like counting zeros for some reason. Don't judge me. Okay, number 4. This is number 4. And that one is 38 times multiplied by 690. So, again, 38 rounds to the tens, this rounds to the hundreds. So I can do that pretty easy by rounding 38 is closer to 40. And multiply 690, 690 is closer to 700. So then I circle my non-zeros, 7 times 4, or 4 times 7, and that is 28. And then I count my zeros, 1, 2, 3, 1, 2, 3. There's my comma, 28,000. Now this would be an example of an overestimate, right? Because we rounded both numbers up. 38 rounded up to 40, and 690 rounded up to 700. So since we made those bigger, that would be a good example of a overestimate. Number 5. Number 5. This will be our last one for just straight algorithms. Move it over here. And that is 82 multiplied by 248. Now, same thing. We're going to round these numbers. 82 is closer to 80. See, I'm an expert by now. 248, I don't know. That might get confusing because it's kind of close. So let's just round this the right way. We look at the highest place value, which is the hundreds. We go next door, and the rule is 4 less, let it rest, or change it to a 0. Okay, so this becomes 200. Good, it wasn't that confusing. Then we can circle our non-zero numbers, which is 8 and 2. So we multiply 8 times 2, that's 16. And then we count our zeros, 1, 2, 3, add them after the number, and then we put our comma for 16,000. I wonder if that counts as an over or underestimate. I don't know. You'll have to figure that out on your own. Okay, so those are 1 through 5. We're going to flip over to page 102, and we're going to work on a word problem here. So let's jam that out. All right, fifth graders, here's our word problem. Lance has 102 packages of sports cards. Each package has 28 cards. Use rounding to estimate about how many cards does Lance have. He has 102 packages of sports cards. Each package contains 28. Let me show you what that looks like before we solve that. Let's just figure this out. So let's pretend that this is a package of cards. And inside this package of cards are 28 cards. So this is like when you go to Walmart or Target and you see, let's say, Pokemon cards, and you pick up a pack, right? There's 10, 11, 12, depends on what kind of pack you buy. There's a certain number of cards in there. Well, for these specific sports cards in the word problem, there's 28 cards, 28 cards in one pack. Well, guess what? He has 102 packages of these cards. So that means this is just one pack. So here's another pack, here's another pack, here's another pack, here's another pack. I'm going to keep going until I have 102 packs. Now that's going to take forever. So that's why we don't solve it that way. We use multiplication, right? It makes it so much easier. So let's go back up to the word problem. Now, I just wanted you to visualize that so you can see what it looked like. And yeah, we could get the answer that way, but ooh-wee, it's going to take a while. All right, let's go back to the word problem. Come over here. So he has 102 packages of sports cards. Each package contains 28 cards. So that's going to be 102 times 28. And we're going to follow the same exact rules we did last time. We're going to round to the highest place value for each number. 102 is closer to 100. Multiply that times 28, which is closer to 30. And nothing really changes here. We circle our non-zero numbers. We have 1 times 3. And 1 times 3 is 3. Count our zeros. 1, 2, 3 zeros. 1, 2, 3 zeros. And then we add our comma for our thousands place value. And our answer is about. Because he did ask about how many. Hey, he's got about 3,000. Good job, guys. One more word problem to go, and that's going to be number 19. All right, this is it, number 19. A company bought 29 computers for $912 each. Estimate the total cost of the computers. Estimate. That means we're going to be rounding, right? Remember our notes, round first, then solve. So let's do that. We're going to have $912 multiplied by 29. Now I'm going to go back and draw a little dollar sign here, just so I remember that's money. I don't want to forget that. And let's look at the highest place value here, the highest place value here. Again, 912 is closer to 900. Multiply that by 29, which is closer to 30. And remember, the reason I did that on my head is because I know that I've mastered rounding. But if you have not mastered rounding, then you need to underline the highest place value, go next door, and follow the rule. 5 or more, raise the score. 2 plus 1 is 3, and then this turns into a 0. That's how I got that 30. And then for 9, same thing. Let's say I don't have the mental math skills yet to do this in my head. I get the highest place value, which is the hundreds here. Go next door. 4 or less, let it rest, or change it to 0, which is what I did down here. So now I have 900 times 30. And this is where it gets easy, right? Circle my non-zero numbers, the numbers that are not 0. 9 times 3. 9 times 3 is 27. And then I count 1, 2, 3 zeros in the entire problem. There's 3 zeros, so I add those at the end. And I put my thousands comma in there. And guess what? It's going to cost about $27,000. That's a lot. Okay, so that's the lesson for today. Thank you for listening. Thank you for stopping by. Make sure that you hit subscribe if you need to find updates on the latest videos coming out for math. This one is listed on the first slide is what page number it is. If you want to follow along, good luck. If you have any questions, reach out to me. Peace.